3 digits. So we will not be doing problems any higher than the numbers you hear, nothing for division into the thousands, although these strategies do apply to larger numbers. So again, just thinking about what division is, we talk a lot about that, making sense of especially word problems. When do we divide? Whenever there is the call to separate something into equal groups, we would divide the number. So it is separating into 4 equal groups, or you're separating yours so that each group has 4. It works both ways. For now, we have no remainders. So the problems that are coming home tonight and that we're doing in class do not involve remainders. We will add remainders in next week. So we'll always be looking, not everything will separate equally with none left over. So we're going to start here. It's called the area model again. 81 divided by 3 is the problem that we're going to be solving. When we solve for area, we were doing length times width, and we found the missing part inside. Well, with division, we already have the area. We know, if you're thinking of this as an area problem, we know the product, but now it's called the dividend in division, is 81. 3 times something makes 81. Multiplication and division are inversely related, so they can help us. We use one to solve the other. So today we learned how to do this strategy. I'm going to take you through it step by step. So we draw the first box, we keep it over to the left side of the paper, we put our dividend of 81, and we put our divisor on the outside of the box. That represents the factor, or the side that we do know. Up here is going to be the part, oh, that's not a good question mark, that we are trying to find out that unknown value. And we're going to do it in chunks, just like we did in multiplication, using our place value knowledge. All right, so when I'm thinking about this story, let's say I have $81 and I want to share it equally with my 3 best friends. How much money would each friend get if I share it equally? So let's think of it that way to give it some context. So I know that I have 3 friends. I know that 3 is going to be a very important number in this problem, and that I'm going to have to be using my multiples of 3 to help me solve this problem. So a strategy that I use to go along to help them solve it is to go over here quickly and do like a quick jot of the multiples of 3 all the way up to 10. So just really quick, I can count by 3s, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So I'm not going to go for 10 because we're going to stay within kind of groups of 10 in place value. So this is 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so forth. The cool thing too is in a moment you'll see that we're going to be also thinking about not just 3 times 1 and 3 times 2, but what if we were multiplying and distributing by groups of 10? So what if I actually was doing 3 times 10? Well, then that would mean I took care of 30. If I did 3 times 20, that's 60. That idea of just adding when you're multiplying by tens, adding a 0. If I'm multiplying by hundreds, I could add 2 zeros, but this is always the root, the base of what I'm doing, these multiples. And you kind of see where that makes sense in just a moment. So we start with my highest place value, which is 8 tenths, or 80. So I have to distribute these pencils into these groups of 3 pencil boxes. So I think about 80, and what I say to myself is if I have enough tens to give these 3 pencil boxes a group of 10 pencils. If I give, here's my pencil boxes. If I give this group 10, and this group 10, and this group 10, well, I would have passed out 30 pencils. Well, that would be great. I take care of 30, but I have 81. So that means that I can also maybe give each group 20 pencils. I could kind of take care of a bigger chunk to start off with instead of doing it 1 here, 1 here, 1 here. So what if I go down, and this is 3 times 20 right here. What if I give each group 20 and 20 and 20? Well, then I will have taken care of 60 pencils. That would be awesome. Well, let's just try 30. What if I could give 30 here and 30 here? That's 3 times 30. I would give away 90 pencils. I don't have 90 pencils to give. So I'm going to go back to, I'm going to even circle it on my list. I'm going to go back to that number of 60. That's the most I can distribute right now is by groups of 20. So when I find that group of 20 that I want to distribute by, I write my 20 up here. It's a partial quotient. I just solved for part of the final answer. 20, remember this is an area model, so it's length times width. 20 times 3 is 60. I already know that because I had it over here. And then I subtract and see how many pencils I have left to still take care of. I have 21 pencils to still take care of. Well, if I still have more to divide or to distribute, that 21 now becomes my new dividend. I've taken care of some of it. I have this many left. Now the problem is 21 divided by 3. Well, once you take care of your 10s and you get down to your 1s, it should be quick facts. 3 times what makes 21? Well, a lot of kids know that one really quickly. If they don't, they go back to this list, they find the 21, the base root, and they realize they skip counted by 1, 2, 3, 4, 5, 6, 7. Oh, I skip counted by 7s to get to 21. 7 times 3 is 21. I subtract it because I passed it out. First I gave everyone 20, then I gave each. You know what? I think I started with a money problem and I started talking about pencils. I apologize if I confused you with the money and the pencils. It really doesn't matter. We could have problems about each, but I think I just flopped back to pencils because we did a pencil problem in class. I'm going to go back to money and I'm going to stick with money. So I just gave everyone $20 and then I gave everyone $7. That means everyone has how much? $27. I added partial quotient 1 with partial quotient 2 to get a final quotient, which is the answer to a division problem, of $27 for each of my 3 friends. All right. It's a lot. Division is one of the harder standards. It takes some practice, takes a lot of talking through it and modeling, and that's why we're doing this tonight. Homework should not be perfect tonight. We're giving it a try, and if we get stuck, we're coming with questions tomorrow to school so we can go over them. So hopefully no tears or frustration, just giving it our best go. Let's try one more together, a 3-digit by 1-digit problem. I'm going to go ahead and, I'm trying to decide what I want to do here. I think I'm going to leave that one for you to look at, and I'm just going to kind of move it here and hope that you can still see. And I'm going to do my second problem over here. I'm going to scrunch it in a little bit. So we are going to try this. We're going to say we're going to do 592. Oh. Now I have $592. And I want to share it equally with 8 friends. All right, got a little more money. Now I'm going to share it with a little more friends. I'm going to stick with money and not switch you back to pencils to confuse you. So I'm going to go ahead and draw the first step of my area model. I'm going to put the bigger number because 592, almost thinking that's the answer. This would be like the product and multiplication. 8 times something equals 592. This is the missing part we're looking for. I'm dividing by 8, and I'm going to be looking to do this in chunks. I'm going to go ahead and skip count by 8s over here along the side because that's going to be an important multiple to know for this problem. I'm going to go 8, 16, 24, 32, 40, 48, what's 9? That's 8 times 6. 8 times 7 is 56. 8 times 8, I'm going to go over here, 64. 8 times 9 is 72, and then 80. Right. 8 times 1, 8 times 2, 8 times 3, and so forth. Remember, I can also think about it as 8 times 10, 8 times 20, 8 times 30, 40, 50, 60, 70, 80, 90, 100. But these numbers here are always my kind of my base. that I go back to. So I'm going to underline those. Not all kids need to list this. This is just a good strategy to start with when you're still learning. And maybe if you don't know your facts as well, to go ahead and list them down. So I'm going to start with my hundreds, the biggest part. I have $500. Well, can I give 8 friends each 100? Well, if I did that, that'd be 100, 200, 300, 400, 500, 600, 700, $800. I don't have $800. I don't have enough hundreds to share right now. So I go to my next smaller place value, which is tens. I'm going to start passing out in 10, 20, 30, 40, 50, 60, 70, 80, or $90 increments. To figure out how many I can do, I look over here at this chart and I think, how can I get as close to passing out 592 without going over? Because I don't have more than 592. So if I look at my numbers here, 480, that's getting closer. 560 is really close to 592. 640 is too big. That's too big. I'm going to circle 560 because that's as close as I can get to 592 without going over. Well, how do we get 560? That would mean I gave my 8 friends 10, 20, 30, 40, 50, 60, $70 each. I could just count by 1. 1, 2, 3, 4, 5, 6, 7. And I add a 0 because I'm doing by tens. Or I could say, I know 8 times 7 is 56. So that means I know that 8 times 70 is 560. I subtract the $560 that I just gave my friends. I just gave everyone $70. That means I used up $560 and I have $32 left to share with them. So if I have $32 left, I need another box on my area model. I move that over. And then now I took care of tens. I get to that easy part of the ones. 8 times what equals 32? I know that pretty quick. 8 times 4 is 32. If I don't know it, I look over here and I see 32. 1, 2, 3, 4. 8 times 4 is 32. I subtract the 32 because I don't have any more. I gave it to my friends. I have $0 left to distribute or pass out. So I add up my 2 partial quotients for a final quotient of 74. 592 divided by 8 equals 74. Or I can also say 8 times 74 equals 592. Right, that is the area model. Very different than the standard algorithm that many of us learned when we were in school, but very important in teaching kids to conceptually understand the whole place value of numbers and not look at just 59. A lot of us would say, well, how many times does 8 go into 59? Well, there's not really a value of 59 there. It's really 590. So we talk about it as whole values in 4th grade. So try your best with this. If you don't know this model, give it a shot learning it with your 4th grader. That might be fun to see in a new way. They will eventually get to the standard algorithm. This is just our starting point. The standard algorithm will come later next year in 5th grade. This model and the next model we'll learn about next week are expanded notation. So those are what we're going to stick with for now. If they've been doing some standard algorithm at home with division, sometimes it can confuse us with this model. Sometimes they see the connections. If you think your child might be confused by it, I would not show it to them at all. If you think they might find it curious or kind of have an aha moment with it, certainly show it to them, but this is one of the models that they'll have to use at school. If they do the standard algorithm, we will ask them to show us the area model or expanded notation too. So just keep that in mind as you're working on division at home. We don't want to confuse our 4th graders any more than we have to. This can be kind of confusing in and of itself. We're just going to keep on practicing.